Okay, review 5.1 to 5.6, solve for x. So on number 1, that is the triangle sum theorem. So you have 180 degrees in that. So you take 180 degrees minus 63 minus 73, and that gives you 44 degrees left. So 44 is this angle here. That's x plus 52. So subtract 52, and we get -8 for x. Number 2, again, triangle sum theorem. So you take 180 minus 70 minus 40, and that leaves you 70 for that angle. So 70 equals x plus 78. Subtract 78, and you get -8 again. Number 3, again, 180 minus 50 minus 75. That gives you 55 degrees. So 55 is equal to x plus 63. Subtract the 63, get -8 again. Number 4, 180 minus 65 minus 60. That's going to give you 55 degrees. So 55 is equal to x plus 61. Subtract the 61, x equals -6. All right, number 5. So we need to get AB. So AB should be the same as CM. So complete each congruent statement by naming the corresponding angular side. So that would be CM. Again, you don't need anything other than that information. So ST should be the same as SB. Those should be very simple to answer. Number 7. Write a statement that indicates the triangles in each pair are congruent. So the easiest way to do this is to go from a single arc to the double arc to the triple arc. So that's triangle JIK. That is congruent to single arc to the double arc to the triple arc. Put a triangle symbol in there. Triangle IJG. Number 8, same thing. Single, double, triple. Triangle CBD is congruent to triangle single, double, triple CBS. Number 9, find the value of x. All right, so you're going to have to use a whole lot of different things here. So x is not one of the two angles that are the same. What you need to do on the isosceles triangles is identify the two angles that are the same. These two are the same. X is not 74. Remember, the angle in between the two marks is not part of the two angles that are the same. So this is 74, that's 74. So there's 180 degrees in a triangle. So 180 minus 74 minus 74 leaves 32 degrees left. Number 10, which two angles are the same? The two that are not in between the two sides. So that means x is 75. Don't have to do anything else. Number 11, which two angles are the same? These two are the same. So you have to take 180 minus 76. That gives you 104 to be distributed evenly to those two. So you have to take 104 divided by 2. So x is 52. Number 12, these two are the same. So this is 40 and that's 40. So take 180 minus 40 minus 40. That's 100. X is 100. All right, number 13. What two angles are the same? These two bottom ones. So if you take 180 minus 88, you get 92. 92 degrees to be spread evenly between those two. So you got to divide that by 2. 46 degrees. Number 14. These two are the same. Done. Okay, so 15, 16, 17, 18. Let's go ahead and go through these. 15. This is 90 degrees. These two are the same. So 180 minus 90 is 90 to be divided evenly in those two. So that's 45. 16, equilateral means equiangular. X is 60. Now in 17, it's hard to see where that's at. Based on where X is in the 118, these both should be in these positions. And both of those are the same angles. So X is 118. Tomorrow on the test, if you're not sure where an angle is, you can ask me. I'll come to your desk and tell you where it's at. Number 18. Which two angles are the same? These two. So that's 68 and 68. So subtract that from 180 and you get 44. Please circle your answers when you're done. Okay, oops. And number 19. So there's a couple different ways to go about this. I'm going to show you the easy way. This big triangle here is a 90-degree triangle. And 138 degrees is an exterior angle. The exterior angle is equal to the other two angles added together. All right, so 90 plus whatever, we'll call this x. So how do I solve for x? By subtracting 90 from 138. What do I get? 48. And if x is 48, 48 and angle 2 are half of a circle, which is 180 degrees, right? So 180 minus 48 gives me angle 2. So angle 2 is 132. So you need to put 132 in this equation. So 132 equals 9x plus 6. And then you just solve algebraically. Divide by 9, and you get 14. Okay. Number 20. We have 115 degrees here. This is a straight line, or half circle. So 180 minus 115, because half a circle is 180 degrees. That little angle is 65. You have an isosceles triangle, which means these two angles are the same. So this is 65. So what is the angle at the top? Well, you got to take 180 minus 65 and minus 65 again. That gives you 50. And since those two angles together are 90 degrees, that means the little angle on the other side of that is 40. And now you have a half circle again. So 180 minus 40 is going to give me angle 2. So angle 2 is 140 degrees, equal to the 10x plus 10. And then solve. (21). So we have an isosceles triangle here at the bottom. So which two angles are the same? These two. So that's 74. So I need the angle at the top here. So 180 minus 74 minus 74 will give me 32 degrees. And then we see that there's a 90-degree angle between the two of them. So 90 minus 32 is 58. Now the top triangle, you also have an isosceles triangle. So these two angles are the same. So that's 58 on the other side. So to get angle 2, we subtract both of those from 180. And you get 64 for angle 2. So that's what goes in that equation. 64 equals 76 plus x. And you get negative 12 for x. Again, we have 109 degrees. There's a half circle. So 180 minus 109 should give you 71. And this is an isosceles triangle here. So these two angles are the same. Remember what I said. identify what two angles are the same if you have isosceles. So the angle at the top must be 180 minus both of those, and you get 38 degrees. And you see that you have a 90-degree angle there. So 90 minus 38 gives you the other one, that's 52. And you see that you have an isosceles triangle on the right. So angle 2 and this one are the same. So 180 minus 52 will give me 128 degrees to be divided evenly between those two. So angle 2 must be 64. 64 equals 4x plus 8. So 64 minus 8 is what? 56. 56 divided by 4 is 14. 23. 77 degrees. So we have a half circle here, or you have vertical angles. So that's 77 degrees. You have an isosceles triangle, so these two angles are the same. So that's 77. And we can't quite get to angle 2 yet, so we got to figure out what the angle is on the left. So 180 minus 77 gives us 26. And we see we have a right angle here. So 90 minus 26 gives us 64. And we also have an isosceles triangle on the top, so 64 is also equal to the top left angle. So you take 180 minus 64, and that gives us the third angle of 52. And we see a half circle there. So 180 minus 52 gives us 128 degrees for angle 2. So that's equal to the 19x minus 5. Add 5 and solve. So 133 divided by 19 gives us 7. Number 24. We have a half circle here. 147. So 180 minus 147 is 33. It's an isosceles triangle. So those two are the same. That's 33. You have vertical angles. So that's 33. And another isosceles triangle. So these two are the same. So the third angle, 180 minus 33, gives us 114 degrees. And you see another half circle there. So 180 minus 114, angle 2 is 66. So plug it into your equation. Subtract the 80. X is negative 14. Okay, number 25. Just going through these, again, these little puzzles. I see a half circle with the 130, and half circle is 180 degrees. So 180 minus the 130 gives me 50. And again, you need to make sure you understand when you have an isosceles triangle, which two angles are the same. That should be the first thing you're doing on every one of these. So these two angles are 50 degrees. Now we also see that we have a 90-degree angle there with the 50. So that means the other one is 40 degrees. And we see we have another isosceles triangle again. So these two angles are the same. So this is 40. And we see with the angle 2, we have a half circle. Half circles are 180 degrees. So 180 minus 40 leaves 140 degrees for angle 2. Now you substitute it into the equation. 140 equals x plus 153. Subtract the 153, x is negative 13. Please circle your answers. Number 26, again, identify your isosceles triangle and the angles that are the same. So isosceles here, this is 132 degrees, it's exterior. So we have a linear pair, that's a half circle. So 180 minus 132 is 48 degrees. Now in this triangle, this is isosceles, so these two angles are the same, not the 48. Remember, the 48 is in between the two sides. That's not part of the two angles that are the same. So you have to take 180 minus 48, and that leaves 132 degrees to be split evenly with the two angles that are the same. So each of those are 66 degrees. Okay? So you didn't need that necessarily, but I've just shown you for practice. You have a 90-degree angle there. So 90 minus 48 will give you that top angle. 90 minus 48 is 42. And again, you have an isosceles triangle. So these two angles are the same. And those two angles make a half circle. So 180 minus 42 gives you 138 for angle 2. Put it in your equation and solve for x. Divide by 12. What's 132 divided by 12? 11. Those of you who know your 11s and 12s times tables. 11. Okay? All right, 27. What is needed for a hypotenuse leg? Well, what's missing in the picture? Well, for a hypotenuse leg, you need the hypotenuse. So the hypotenuse, those have to be marked. And it's already a given that DC is the same as DC in both triangles. So you have the reflexive property there. But all you have to do is mark the hypotenuses on that one. On 28, you need angle, side, angle. So look at what you have. You have an angle and you have a side. So where's the other angle? Should be at angle E and angle K. So you had to mark both of those. On 29, again, hypotenuse leg. The hypotenuses are marked. You have to mark a leg. So make sure you mark the same leg. If you marked FE, then make sure you mark AB. Number 30, angle, angle, side. Well, we have one angle listed, and we have the reflexive side. And you can mark the reflexives if that makes you feel better on those, okay? And then you need an angle. It makes a difference which angles you choose. If I choose this angle here, then I better choose the angle up to the right, or vice versa for each of the other ones. So there's your angle, angle, side. So 31, hypotenuse leg. Well, the leg's already marked, so you need to mark the hypotenuse. Make sure you use your hash marks properly. Should be 2 hash marks on each of these. 32, angle, side, angle. Again, mark your reflexive. You have angle, you have your side, and then make sure you mark the right angle. For angle, side, angle, the side has to be attached to both angles. So that's your answer for that, 32. All right, 33. Let's just do it this way. 33, side, angle, side. So the angle has to be in between the two sides. So here's the side. There's your angle, so the side should be WY. Same thing for TS. Oops, use 2 because it's a different length. All right, let's go on to 34. Side, 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 make sure you mark it correctly. So if you put 2 marks here, that's fine. Make sure you put 3 marks there. If you put the 2 marks at the SR, then the 3 marks go in the middle. Make sure you mark it correctly. 35. Angle, angle, side. So we already have our side. Do not mark this angle. That would be angle, side, angle. So we must be marking angle Z and angle J. So there you have angle, angle, and then the side. 36. Again, angle, angle, side. Well, we have one side shown. Where are the 2 angles? Can you tell me where one angle is? Vertical angles. Vertical angles are congruent. So that dictates which other angle we use. If you chose X, that would be angle, side, angle again. That's wrong. So it has to be V, and it has to be Q. Angle, angle, side. Number 37. Angle, side, angle. So the side is in the middle, so it has to be attached to both angles. So it has to be EF, and it has to be YZ. It cannot be any of the other sides. 38. Side, angle, side. Well, we have the reflexive side. So mark it. There's your reflexive side. And the angle is in between both sides. So the angle is attached to both sides. So that means it has to be XW and NW. Determine if the 2 triangles are congruent. If they are, you state how. By using side, angle, side, 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 hypotenuse, leg, blah, 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 okay? Or, if they aren't, you say not enough information, NEI. So we have vertical angles here. So that's side, angle, side. On 40, we have a reflexive side. So that's side, side, side. It's not what we need to add to the picture. The vertical angles are understood to be congruent, and reflexive is understood to be congruent. Those are your theorems. Okay, 40, that was it, right? So let's look at these proofs here. Let's start with number 1. We'll just try to make this easy here. This is your given, and your proof statement should be down at the bottom when we're done. So let's see here. SE and EM, it is marked in the picture. Okay, and SY and YM, that's marked. So just looking at the picture, are the 2 triangles congruent, and how do you know? All right, so YE is congruent to YE reflexive property. And so now triangle SYE is congruent to triangle MYE, side, side, side. Number 2. Again, we'll just call that our given. Make sure it's marked in your picture. BD bisects AE. What does it mean to be a bisector? So if it's not marked, we mark it. BD is the bisector of AE. Make sure you mark the right one. So those 2 pieces, AC and CE, are congruent. Let's say that AC is congruent to EC. Definition of bisector. Now at the given, we also have angle E and angle A congruent. Those are marked in the picture. So we've marked our bisecting segments. Can we prove the 2 triangles are congruent? Yes or no? Well, the answer is yes. We're trying to get you to prove it, but do you see it? Emma, what do you get? Angle, side, angle is going to be the reason. So triangle ABC is congruent to triangle EDC, angle, side, angle. Well, on the picture, I only have an angle and a side. But you should recognize you have vertical angles. So angle ACB is congruent to angle ECD. Vertical angles theorem. All right, number 3. So we have our given again. Mark your picture with what the given is. And then whatever you're marking on top of that, make sure you give the reason for it. So PS is parallel to RT. PS is parallel to RT, and those are marked with those little triangles. PQ is equal to TQ. PQ is equal to TQ. Equal. Says equal. I think that should have said congruence, but since it says equal, we have to address that. If they're equal, they're also congruent, right? So if it's written like that, then you need to say PQ is congruent to TQ. Definition of congruence. All right, so that's been taken care of, just in case that was an error. And that's marked. So anything else that's obvious in that picture? Vertical angles, so let's hit that right away and say it. So PQS is congruent to angle TQR, and that is vertical angles theorem. So now we have an angle and a side. So we're looking at side angle side or angle side angle. And anytime you have parallel lines, you should be thinking consecutive interior angles, alternate interior angles, corresponding angles. So we have two parallel lines cut by a transversal. So you could say alternate interior angles for those two. So I'll erase all that I just did and write it on there again. Alternate interior angles. So say it. Angle SPQ is congruent to angle RTQ, alternate interior angles. And therefore, triangle PSQ is congruent to triangle TRQ. What is it? Angle side angle. All right, good. Number 4. It's a crazy looking problem. Okay, so let's go through each of these things separately. ED is perpendicular to EC. All right, so that means we have a right angle that are perpendicular. So how do I know it's a right angle? Because of what the definition of perpendicular means. All right, so I need to move this over here. Okay, so let's say angle DEC, angle AEC, angle, those two, I guess, are right angles. Definition of perpendicular lines. So those two are right angles. Okay. The next thing we have is another perpendicular line, BD and BC. So that makes these right angles. So again, you say the same thing. Angle ABD and angle CBD are right angles. Definition of perpendicular line. So you could say all that together on one line if you wanted to. All right, we have one more thing on the given. We have ED is congruent to BC. So mark that on your picture. ED is congruent to BC. So what are we trying to prove? Triangle CED. So I'm going to draw these separately so we can see it in both situations, together and apart, CED. So I'm going to also mark them separately. All right, so that's that, and that's that. So I see either a side angle side, or an angle side angle, or maybe hypotenuse leg. Anytime you see 90 degrees, you should think possibly hypotenuse leg, which you should see that in this picture. DC is reflexive. So you would say DC is congruent to DC, reflexive property. Definitely look for vertical angles, reflexive properties to help you out in this case. So now we have that marked, and in the pictures down at the bottom, it's easier to see that triangle CED is now congruent to triangle DBC by hypotenuse leg. So we have our given, and let's mark everything. BD is a bisector of angle ABC. So BD bisects this angle here. So these two angles have to be the same. So we mark that. And we say angle ABD is congruent to, angle CBD. Definition of bisector. Of angle bisector, if you want to be more specific. And then we have the reflexive side here. BD is the same as BD in both triangles. So BD is congruent to BD, reflexive. And I skipped part of the given there. Let's go back to the given part. We have AB and BC. Make sure you mark that, AB and BC. And then we have our reflexive. And that's enough, because now you say, oh, we're proving that AD is congruent to CD. All right, so you haven't been able to do this yet. When we come back from Thanksgiving break, I'm going to show you how to prove that. On the test, this would have said, prove that triangle ABD is congruent to triangle CBD. So why are those two congruent? Why are the two triangles congruent? What's marked? Side angle side. All right, so when we come back from break, once you prove the two triangles are congruent, then aren't all the corresponding positions congruent? Isn't that what we said in the very beginning on 5.1? Yeah, so if they're congruent, all the angles are congruent and all the sides are congruent. So then you could have said AD is congruent to CD, but I'll tell you that when we get back from break. All right, and then at the end of the video, next page, which you do not have on Google Classroom, are all your answers except for the proofs. So tonight when you're working on this, if you want to just go to the end of the video and check those, you can.